Continuing with section 8.1, final example, example 6. Yes, it's a word problem. I apologize, but we have to do at least one. Well, it turns out there's a lot of problems that can be solved with a system of equations, particularly if there's more than one quantity you're trying to find. So if there's two quantities you're trying to determine, if you can set up two equations that relate those quantities, then you can set up a system of equations and then solve the system by either substitution or addition, as we've demonstrated in our earlier examples. So here's example 6. Mr. Sharma invested a total of $30,000 in two ventures for a year. The annual return from one of them was 8%. That's basically like earning interest. Okay. The other paid 10.5% for the year. He received a total income, that's like from the interest, of $2,550 from both investments. How much did he invest at each rate? That is, how much did he invest at 8%? How much did he invest at 10.5%? Now, looking at our table, it's very helpful to have a table like this in setting up your equations. We know that he invested a total of $30,000. So I'll put that there. We also know that the total income earned was $2,550. So we can add that in as well. The amount invested in each venture, each account, those are the unknowns in this problem. So we want to know how much was invested at 8%, how much was invested at 10.5%. So let's just call one of them X, call the other one Y. Okay, now the amount earned for the 8% investment. Well, it's 8% means you take 8% of the amount invested, and that's how much you earn. It's essentially simple interest for a year. That's going to be our interpretation. So 8% of X is 0.08x. We write 8% as a decimal. And 10.5% of Y would be 0.105 times Y. So we filled in everything in our table. The only thing left is to write a system of equations. And it stands to reason that the amount invested at 8% plus the amount invested at 10.5% should add up to the total amount invested in both ventures, $30,000. So that gives us our first equation. X plus Y equals 30,000. It would also stand to reason that the amount earned from each investment should add up to the total earnings. So the amount earned at 8% is 0.08x. The amount earned at 10.5% is 0.105y. Those amounts should add to the total earned, 2550. So now we have a system of two equations and two unknowns. These are both linear equations, and we can use either substitution or addition to solve the system. Now, for a system like this, with the first equation being so simple, it's very easy to solve it for either x or y. For example, if I solve it for y, I get y equals 30,000 minus x. So if we replace y in the second equation now with 30,000 minus x, we can eliminate y and we get an equation in just the variable x, and we can then solve for x. We're just solving a linear equation in one variable. So rewriting the second equation but substituting for y, we would obtain 0.08x plus 0.105 times, in parentheses, 30,000 minus x. Then that's equal to 2550. And then the rest is fairly straightforward. You might need a calculator. 0.08x plus, we're going to multiply 30,000 by 0.105. That works out to 3150. Then we're going to distribute 0.105 to the second term in the parentheses. That's the minus x. So we obtain minus 0.105x equals 2550. We can combine the first term and the last term on the left-hand side. Those are like terms. We just subtract 0.105 from 0.08. That's going to give us a negative number, negative 0.025x. And then let me just rewrite the 3150 for now, and 2550 on the right. So now let's subtract 3150 from both sides. So 2550 minus 3150 is negative 600. Then divide both sides by negative 0.025. And when you divide, you obtain 24,000. That would be the amount invested at 8%. The amount invested at 10.5% would be 30,000 minus the amount invested at 8%. That is, y equals 30,000 minus x. That's going to be 6,000, of course. So, conclusion, he invested $24,000 at 8% and $6,000 at 10.5%. And that concludes example 6, and that also concludes our notes for section 8.1.